All right, moving forward with some of our derivative application stuff. How do we use our derivative? What is it telling us? I've got two theorems up here ready to go. We got lots going on. This chapter, this unit is called the mean value theorem. Sounds mean, like the word rude or not nice, whatever. But mean is more applicable to the mathematical term mean, which is kind of an average, right? So we're going to see what that means. So we've got two theorems we're going to work through with some problems and see how you do. Okay, so this first one is called Rolle's theorem. It says if the function f is continuous from a to b, differentiable from a to b, has to be continuous on the closed interval and only differentiable on the inside. So the endpoints aren't going to cause us issues with that differentiability. And the endpoints have to be equal. Well, that means there's at least one value of c, where c is between a and b, where our derivative is going to equal 0. So I've got a graph here where my two endpoints are equal. For me to have this continuity and start and end in the same place, somewhere on this graph, I have to have at least one place where my derivative equals 0. In this case, I have 3, but that's not guaranteed. We're saying there has to be at least one. So to be differentiable, no corners, cusps, vertical tangents, has to be continuous, no jumps, leaps, holes, none of that. No asymptotes, has to be nice and smooth. You are guaranteed one spot where the derivative is equal to 0. Okay, so the problem here, I have a quadratic, and we want to know where that derivative equals 0 between the two x-intercepts. The reason we're going to use the two x-intercepts is because we then know they're equal. That's a point where the starting and end point are going to be the same. They're both crossing that x-axis. So if we want to know where those x-intercepts are, helpful to make sure that we're continuous and differentiable. It's a quadratic. We know that's continuous. We know it's differentiable. But we can go ahead and set this equal to 0, and I'm going to factor that to x minus 3 and x minus 2. My x-intercepts are 3 and 2. So there is some point between 3 and 2 where my derivative is going to equal 0. Guaranteed. Because this is continuous and differentiable between 3 and 2. Well, then where? So I'm going to take the derivative, which is 2x minus 5, and I'm going to set that equal to 0. So 2x minus 5, I'm going to add the 5 over, divide by 2. So at the point where x equals 5 over 2, my derivative equals 0. Okay, cool. Mean value theorem. Similar idea, but a little different. If f is continuous on an interval, closed interval, and differentiable on the open interval, then there is at least one c where the slope at c is equal to the average slope. So again, that term average, mean, average, they connect there. So what we're seeing here, this red line is the slope between the endpoints, A and B. So there's that slope. But then this green line is parallel to the red line, which means they have the same slope, and it's happening at this value of C. So I want to know where the derivative equals that slope. So first thing I'm going to do is I'm going to find the endpoints. I need to find the slope between A and B. So to do that, I'm going to plug in -1. So that's going to give me -1 plus 3 plus 5. So that's going to give me 7. So I'm going to have the point -1, 7. Then I'm going to plug in 1. So that's 1 minus 3 plus 5. It's -2, so that's 3. Right? 1 minus 3, -2. Yep, cool. So now I'm going to find the slope between these 2 points. So I'm going to do 7 minus 3 over -1 minus 1. So I'm going to get 4 over -2. That slope is -2. Obviously, it's not this. It's an example problem. So my slope is negative 2. I want to know where else that graph has a slope of negative 2. So I'm going to take the derivative, which is 3x squared minus 3, and I'm going to set it equal to negative 2. Where does my derivative equal negative 2? So I'm going to add 3. So 3x squared equals 1. Divide by 3. Oh, I'm a little off screen there. And so now I have x squared equals 1/3. And I'm going to go ahead and square root both sides. So x equals plus or minus the square root of 1/3, which if we were to rationalize, that's going to give us root 3/3, plus and minus. So that's actually happening at 2 different places. Okay, they're not nice, pretty numbers, but when x equals root 3/3, our slope is going to equal negative 2, and negative root 3/3. It's going to equal negative 2. Okay, make sense? Mean value theorem? Okay, go forward and do your best.